Hi there. Let's look at multiple choice questions 4, 5, and 6. Questions 4 and 5 are based on the following information. So, a 1 ounce serving of a certain breakfast cereal has a mean of 110 and a standard deviation of 10 calories. So, next we have a cup of whole milk, random variable also with a mean though of 140 calories and a standard deviation of 12 calories. Your breakfast is going to consist of 1 ounce of cereal with a half of cup of whole milk. So your total calories, which is what we're interested in describing, the total calories represent a full serving of cereal, I'll call that C, plus 1/2 of a serving of milk. I'll call that 1/2 M. Again, C is a random variable. It has a mean of 110. It has a standard deviation of 10. So cup of whole milk, mean of 140, standard deviation of 12, but I'm only going to use a half of a cup of milk, and we're going to use a full serving of cereal. So the mean of T then, literally, we can substitute in the mean of C, that's 110, plus half of the mean for milk. The mean for milk is 140, so half of 140 is 70, and 70 plus 110 is 180, so the mean of the total number of calories, T, would be answer C, that's 180. So for the standard deviation, we have to believe that these two random variables C and M are independent of one another. If they are independent of one another, then we can add their variances. So I'll write it down here. Let's start with C's variance. So for the variance of C, its standard deviation is 10. What I need to do then is square that to make its variance. To that, I need to then add the variance for M. So for milk, the standard deviation was 12. That makes the variance 12 squared. But notice, I'm not just combining the variance of C and M. Milk has been adjusted by 1/2. Now notice that this variance is a squared quantity. So what that means is I also have to multiply by the 1/2, the quantity squared. That then is my expression for my variance. To get the standard deviation though, which is what I'm trying to find, I need to take the square root of the variance. So go to the calculator here. 10 squared is 100. Plus, we'll take the 1/2. We'll square that. And then we will multiply by the 12 squared, that's 144. That gives us a total variance of 136, and we can take the square root then of the 136. And that will give us about 11.6 calories for our standard deviation, and that should be answer D. So, question number 6. In which of the following situations would it be appropriate, and that's the key, would it be appropriate to use a normal distribution to approximate probabilities for a binomial distribution with these values of n and p? Well, the criteria that we need the number of successes, that's n times p. I want that to be greater than or equal to 10, and at the same time, I want the number of failures, n times 1 minus p. I also want that to be greater than or equal to 10. So notice that won't happen here. In part A, 10 times 0.5 will give me 5. That is not greater than or equal to 10, so answer A is out. Now notice this answer here, the 40 times the 0.88, that will be greater than 10. That's no problem. The trick, though, is that the 40 times 1 minus the 0.88 will not meet our criteria. Take a look. So here's the 40 times the 0.88. This would be the number of successes in this case. Yes, that does exceed 10. However, 40 times the number of failures, or rather the probability of failure, that would be 40 times 0.12. That only gives us 4.8 failures. Notice there were a total of 40 trials, so once I knew there were 35.2 successes, I can just subtract the 35.2 from 40. That will give me my expected number of failures. So answer B is also out. So for answer C, 100 times 0.2 would be 20. 100 times the probability of failure, 0.8, that would be 80. So this looks like it works. Let's check the others while we're here. Notice 100 times 0.99 will give me 99 successes, but that only leaves me with an expected number of failures of 1. So it can't be D. Same problem here. 1,000 times 0.003, the number of successes is only 3. So that does not equal or exceed 10. So that tells us that our answer is C.